Okay, Wildcats. Today we're going to 1, odds and evens, power functions. Student works 1, 2, 3, and 4. All right, let's take a look at the next page. Getting started. Flat in the middle. You have studied linear functions, quadratic functions. Now you will explore more polynomial functions. A common type of polynomial function which you would have studied is a power function. Power function is a function of the form p of x equals a times x to the n, where n is a non-negative integer. Consider each power function and its graph in the sequence below. For each graph, identify the domain of range, x-intercept, and y-intercept. So the domain for y equals x is negative infinity to positive infinity, negative infinity to... correct that here. Negative infinity to positive infinity, negative infinity to positive infinity. The x-intercept is 0, 0, which is right here. Okay, for y equals x squared, the domain is from negative infinity to positive infinity, range is from 0 to infinity. The y-intercept and x-intercept are both 0, 0. And then for y equals x cubed, the domain is negative infinity to positive infinity, range is negative infinity to positive infinity, and the x-intercept and y-intercept are both 0, 0. All right, go ahead and finish that up. All right, let's take a look at the next page. Activity 1.1, exploring reflections in symmetry. In this activity, you will make connections between the reflections and the symmetry of the graph of the function. Consider the sequence of graphs shown. F of x equals x, f2 of x equals x squared, f3 of x equals x cubed. What happens when the a value is negative? Write each function in terms of x and then sketch it. So negative f1 of x equals negative x, negative f2 of x equals negative x squared, and negative f3 of x equals negative x cubed. Okay. Now the domain and range of negative x are negative infinity to positive infinity, negative infinity to positive infinity, and the x and y-intercept are both 0, 0. For a negative x squared, the domain is from negative infinity to positive infinity. The range is from negative infinity to 0, and the x and y-intercept are both 0, 0. For a negative x cubed, the domain and range are negative infinity to positive infinity, negative infinity to positive infinity, and both x and y-intercepts are both 0, 0. All right, go ahead and finish that up. Well, let's take a look at the next page. What happens when the b value is negative? Write each function in terms of x and then sketch it. F of negative x is negative x. F of negative x is positive x squared. F of negative x is negative x cubed. Okay, so domain is from negative infinity to positive infinity, and both x and y-intercepts are both 0, 0. The domain for x squared is negative infinity to positive infinity, bracket 0 to infinity, and both the x and y-intercepts are both 0, 0. And then for negative x cubed, it's negative infinity to positive infinity, negative infinity to positive infinity for both domain and range, and x and y-intercepts are both 0, 0. All right, go ahead and finish that up. All right, let's take a look at the next page. If a graph is symmetric about a line, the line divides the graph into two identical parts. Special attention is given to the line of symmetry when it is the y-axis. When a function reflects onto itself across the y-axis, the function is even. Determine which graphs from question 1 are symmetric about the line. What is the line of symmetry? The graph of the function f of x equals x squared is symmetric about the line x equals 0. All right, go ahead and mark off this. All right, let's take a look at the next page. The graph of an odd degree has basic power function is symmetric about a point. In particular, the origin of function is symmetric about a point if each point on the graph has a point the same distance from the central point, but in the opposite direction. Special attention is given when the central point is the origin, as it determines the function is odd. When the point of symmetry is the origin, the graph is reflected across the x-axis and y-axis. If you replace both x and y with negative x and negative y, the function remains the same. Worked example. Consider the function f of x equals x cubed. You can think of the point symmetry about the origin as a double reflection. So go ahead and read and look over the worked example. So when f of x equals x cubed, here's your graph. The function f1 of x is shown. When f2 of x equals f of negative x, it's equal to parentheses negative x cubed, which is equal to negative x cubed, which is this graph. And the function f1 of x is reflected across the y-axis to produce f2. Then when f3 of x equals negative f2 of x, that's negative times negative x cubed, which is x cubed. The function f2 of x is reflected across the x-axis to produce f of 3. An even function has a graph symmetric about the y-axis. Thus, f of x equals f parentheses negative x. An odd function has a graph symmetric about the origin. Thus, f of x equals negative f of negative x. Use what you know about A and B value transformations to describe even and odd functions in your own words. Even functions are identical to their reflections across the y-axis. Odd functions are identical to the reflections across the x-axis and then the y-axis. All right, let's take a look at the next page. Explain why the reflection of an odd function across the y-axis produces the same graph as its reflection across the x-axis. Then use function notation in the conclusion. Let's let f of x equals x cubed. An expression with an odd exponent like x cubed is an equivalent to f of negative x equals parentheses negative x cubed, which is equal to negative x cubed. You determine algebraically whether a function is even by evaluating the function f of parentheses negative x. If f parentheses negative x equals f of x, then the function is even. You can also evaluate the function at negative f of x if negative f of negative x equals f of x, or negative f of x equals f of negative x, then the function is odd. State whether the graph of each function is shown as symmetric about a line. A is symmetric across x equals 0. Okay. B, there is no symmetry. And C is symmetric about a point. All right, go ahead and finish up that page. Okay, the student works 1 and 2. All right, let's take a look at the next page. The student works 1, 2, 3, 4, 5, 1A, 1B, 2A, and 2B. All right, let's take a look at the next page. The student works 1, 2A, 2B, 2C, 2D, 1A, 1B, 1C, 2A, 2B, 3A, and 3B. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.